next technical talk is by Julie Sparks. She is a security engineer at Brex. So Julie, if you're on, I'll give you the stage.
Hello, thank you. You go ahead and pull up my slides. Awesome, thanks so much for having me. I wanted to dive a little bit into something that I work a ton on, which is detection engineering. This is a subset of security incident response and a lot of security engineering efforts that happen on the blue team. So in this crash course over the next 30 minutes, I'm hoping to give everyone listening an insight into what exactly detection engineering is, the process of building a detection, and then some examples of how you can do it for yourself. So a little bit about me. I'm currently a detection and response security engineer at Brex, which is a fintech startup based out of San Francisco. I've worked at a couple other security companies before this. I added a photo of me in front of the infamous Cloudflare lava lamps. For those who are unfamiliar with it, it is how Cloudflare bases their cryptography off of the randomness of the lava lamps in their San Francisco office. So I highly recommend if you're ever in San Francisco to go check it out. It's very cool. I'm currently located in Denver, Colorado. And some of the things that I do outside of detection engineering are rock climbing, learning various new things, and cooking. So the term detection and response is fairly new, but it is a blue team role. Some other ways you could have heard it phrased is like a security operations team is similar, a threat research team, detection engineering team. All of these are broader versions of a detection and response team, where you see detection and response teams typically at smaller companies where you have a couple engineers that are doing a ton of different roles. And they're not able to specialize as much, and you don't see those huge teams. But these security engineers get to do a little bit of everything. They get to work on the security incidents that come in, triaging alerts, running any investigations that need to happen, building internal tooling, so pipelines, standing up like cloud infrastructure, all of those things fall under the detection response team, as well as like threat research and writing security detections. So often on these smaller teams, the way it can be structured is that you'll go on call for a set amount of weeks every quarter. And that's when you'll be helping with incident response. And then when you're not on call, you're able to focus on the engineering efforts for the team, whether that's like automation, working on data pipelines, or writing security detections. So a little bit of security detections 101. Before I start talking pretty in depth about this, I wanted to give everyone a chance to read the slide. I won't read all of it, but I'm just going to go over like the top 3 things that I think you need to know to make this talk not confusing. So logs are like the bread and butter of detection engineering. You can't detect things if you don't have records of them happening. So you can get logs from any system, whether that is like Google Drive, off of like network device, off of your own laptop. Logs exist everywhere, and whatever logs you have access to, you can use those to build detections. A detection for the use case that we have is a logic or function that matches on a specific pattern. So this can be like logic operators. So like if this event happens and this event happens, or like if then statements, or it can be written in code like in Python. So it really depends on like what tooling you're using. But any way that you can write basically code or logic that matches on a series of events. And then if that detection evaluates to true, then you want a notification that that has happened. And that's what an alert is. So you go all the way from having your logs, writing the detection on them, and then getting the end alert. So the purpose of writing security detections is to catch all the bad things that are happening in your environment. So you don't want to get notified when like mundane actions happen. You don't want to have to sift through all of your logs every time you're looking for something suspicious. You want to know that if a suspicious thing happens, that you're going to get an alert. And so that's where security detections come in. They're generally just part of this greater incident response lifecycle. So I'm sure a lot of folks are familiar with responding to incidents. A lot of times the security incident starts because we get an alert from a detection, that has detected malicious activity. And so the investigation starts and kicks off based on that behavior that was already researched and written and executed. One of the great parts about incident response is that it's all cyclical. So all the findings of your incident response can then feed back into your detection writing and research. This security detection lifecycle is a great way to think about walking through how you would determine what you're going to try to detect, writing the detection, testing it, kind of similar to like an SDLC, like a software development lifecycle. But it's really important to know what logs you have access to. Every company has different environments, different systems they run. And what can be challenging for security engineers is that just because a system exists doesn't mean the security team has access to those logs. And so when you're thinking about what you want to try to write a detection for, you have to know what logs that you have incoming. And then you can start thinking about what threats are able to be detected based on those logs. So I've referenced the MITRE ATT&CK framework. This is a pretty industry standard way of classifying techniques that attackers can use. If you haven't read it before, I highly recommend. It kind of gives you an idea of, based on like, if you're looking at initial access attacks, like how can someone compromise an account? It gives you different behaviors to look for. And then you can also use that to make sure that you're covering all the areas that you need to for a specific system. So it's really helpful. And also like, it's really big for like management executive to know your coverage against this like industry standard. So both as like a beginner and like someone who's like been in it a little bit longer, like it's still incredibly valuable. Once you have an idea of what type of behavior you're looking for, you can then research that in your environment. So often you'll have a repository, like a centralized place of logs. You can research if that behavior has occurred in your environment before and really dive into, has it occurred because it might be something malicious? Has it occurred because it's common behavior in your environment? And it really gives you an idea of what like actually happens. Because every environment is different. Just because you've seen this behavior in another environment and is malicious doesn't necessarily mean it is in yours. It's all based on how things are set up. And so you can compare that to what is happening internally and then look at open source documentation and understand how that threat occurs in other people's environments and kind of just build your hypothesis on how you think this detection should work, what it should tune out, and how to best approach the problem based on your resources. So once you kind of have your test detection, you can work through different samples of logs and see if this behavior occurs, if it would match, and then do a ton of documentation, put down all of your processes, all your steps that you took, and then have other peers, whether inside your team or external to the company, review it and see if it makes sense what you're trying to build and if they have any feedback, because that's incredibly important. A lot of times people will see edge cases that you might have missed and help really make your detection more robust. There's a couple different ways that you kind of start writing a detection. So oftentimes when you're on a detection and response team, you don't have just like a ton of time in the world to just like think abstractly about what you might want to detect, as fun as that would be. Usually you're pretty busy. And so you kind of have to have an event that spurs writing the detection. So oftentimes we will do threat hunting or threat modeling, which is usually when you have an exercise that looks at a system and then you think of different ways that system can be attacked and you look at potential like bad events that could occur. And then you use those findings to write detections. And that can be a really amazing way to get really valuable detections because you've already done a huge bulk of the research. Another way that detections sometimes come about is with security incidents. So if a company finds out a user has been compromised, then the investigation is used as research input. So you can say, hey, when I was looking at accounts that were compromised, I was really interested in IP addresses. And that's what I wrote a bunch of detections on, was these like malicious ranges of IPs. However, when we see an actual account get compromised, we see that it was because of service accounts. And so then you understand and you have the backing of the security incident to then write detections based on service accounts. And so it kind of gives you a better idea And then these detections are more applicable for your environment, right? Because you've seen security incidents in the past that have happened related to that event. The last kind of big trigger for writing detections is if you get you onboard a new vendor system, or there's a new like regulation or a law passed. So a big example of these are like sanctions, data privacy laws. A lot of times we'll get requests from the legal or privacy team saying this has happened. If this occurs in our environment now, we need to know because it's we can be prosecuted for this behavior. So that can be like a little bit more mundane, but like really important for the company. Not as much fun research because it's pretty much spelled out in the regulations. But what it can be really fun is if we onboard a new vendor and then we're understanding what type of logging is available, how the system interacts with the rest of our systems, and like what can provide value based on that MITRE attack framework to understand if something malicious were to happen related to the system, how would it play out in the logs, and like what can we do to build a robust detection to alert us when that happens. So you can basically write a security detection on anything that produces a log. So it's a lot of things. For the purpose of this 30-minute talk, we're just going to think about SaaS resources. I think it's pretty easy for people to wrap their head around because you can think of like Google Drive, Office 365, Okta, Gmail, like all of these are SaaS applications. And so any action that you take in those applications is logged, and we can use those for writing good detections. The MITRE attack framework actually has a specific matrix to SaaS apps. This was released last year, and it's great because it takes the larger framework and pares it down to what's actually relevant when you're thinking about SaaS applications, because they're very different than thinking about an on-premises Active Directory, for example. And so based on this matrix, we can say, if we're looking for an attacker establishing persistence, we're going to write detections that utilize manipulating valid accounts and really dive into making detections for each of these different techniques. That way we know we have good coverage for that specific system. I like to say there are probably like 3 buckets of common detection types. So when you're writing a detection, based on what you're trying to detect, there are a lot of different like logical approaches you can take. So oftentimes, if you know that there is one event that should never happen, and if that event happens, it is malicious. And that's a single event detection. It's a very simple one. You can do a lot of these in the beginning, but as the attack patterns get more and more complex, it's a little bit unrealistic to say that one event can categorize like an entire behavior as malicious. An example, though, of this is if a user logs in from a known malicious IP address, or, for example, if a user logs in from a country that's under sanctions. Those are like events that it doesn't matter any other data in the log. If that happens, it's bad. And so that is creating an alert. More realistically, like you're going to chain together multiple events over a time frame to illustrate a behavior. And that's what you're going to build a detection on. And so that would be a multiple event, or it's sometimes called a composite detection. So the example is if there's multiple Google Drive API calls by a non-internally built application, then you want to trigger an alert. So you're specifically interested in the fact that there is multiple API calls. Perhaps it's an API call first to the Google Drive API, but then there's a similar call to the Google People API, and you're starting to see these behaviors of people trying to pull different information from the same account. And so that's something that would be really great to write a detection on. The last one is probably the least used in the industry. It requires a lot of internal resources. It's really expensive to run machine learning models. However, some companies, especially bigger ones, do invest the time to clean up their data and make really good machine learning models. Usually you would use these when you're trying to find anomalies in a specific user's behavior. So you see it when you might get an alert if a user who's in Europe is working US hours, and they almost never work outside of their normal business hours, and they're trying to access sensitive resources. So this is something that you can't really write a static detection that relies on like an event pattern, because if they do these events during their regular business hours, it's not malicious. However, the anomaly is them doing it at a different time. And you could also look at different IP addresses, different locations, but you're trying to create a profile of a person and then see what happens outside of that like profile that's built. Again, I'll mostly focus on the first two types. The machine learning model is a little bit outside the scope of this talk. So I'm going to walk through building a quick detection, just so you can kind of get like some like examples to sink your teeth into. The threat scenario I'm thinking of is a social engineering attack has started at your company. The attacker is calling employees, asking them to log into a fake Okta page that captures their credentials. So it's actually an incredibly common attack that happens against companies, I would say in the last couple of years. And this is incredibly dangerous if your company does not have multi-factor authentication required. So let's dive into how you would detect if this happens. So an employee could report that they see this fake Okta page, but you shouldn't just rely on employees reporting things. So you should also be looking at every login attempt to your systems and trying to understand if that is malicious. For people who aren't familiar with Okta, it is an identity platform that a lot of companies use for single sign-on and authenticating their users into internal systems. So it's a great log resource because it will show every login event to an internal system with lots of context information, and then it will show you what applications they've accessed. And for those who are familiar with the MITRE ATT&CK framework, this is what you use for your initial access detections a lot of the time. So in this great log example pulled from Okta's website, you can see that you get information on their email, their name, their user ID, the user agent. You get information usually about their like operating system and browser pulled from the user agent, as well as like some good geographical context information. And usually for Okta, these are actually pretty accurate. So based on what is available in the Okta logs, so this is assuming you have no way to like add enrichment into your data, you're just looking at the log itself. There's a couple things you can look at to try to understand if it's a legit sign-in attempt from an employee. You're going to look to see if it's a sign-in from a new device. Like, have you seen that user agent before? And have you seen the user agent tied to that employee? If an employee is only supposed to be accessing company resources from their work device, then you can assume that that device should be pretty static. You shouldn't see a ton of different user agents. You can also look at the IP address. I always check to see if the IP address is a residential ISP. All of our employees are remote. I assume that they're going to be working from home. And so if it's not a residential ISP, and maybe it's like a VPN or if it's a proxy, that's when that can be a red flag that this is actually a bad actor logging into their account. And then also looking at the time frame. So a combination of all three of these would be like a really high fidelity detection. Sometimes based on your logs, you can only incorporate one or two of these event patterns. But if someone is logging in from outside of their working hours with an IP address that has no malicious behavior and has a different user agent than expected, you can say with fair confidence you think this user is compromised. So one aspect, this is actually a login example from when I was at Cloudflare, this gorgeous log. If I'm looking at someone who successfully logged in, that is a US employee, but is logging in from outside the US, and they're not vetted for travel, then maybe I would write some detection like this. This is just like an example. It's pretty like vendor agnostic. But if the event outcome is a success and the country that the log is coming from is not the United States, but I'm in an Okta group which often companies will use octagroups to separate access and access based on location, role, etc. In this case, I'm assuming that there's an octagroup for US employees. And so if I'm not logging in from the US, but I'm a US employee, that could be a red flag. And we can use that to build a further detection. So once you have this detection written, it's really important to test it just like you would any other software. Hopefully you have access to a testing environment. Sometimes people have to test in prod. We've all been there. But hopefully you can run it against a bunch of logs that have happened historically in your environment, like a subset of them, to see if it will evaluate to true on behavior you're expecting. If not, maybe you can emulate that behavior in your testing environment and see if the log generated matches your detection. This is also a great time to understand if there's any false positives. Sometimes you come into a detection thinking there's no way there's going to be any employees logging in from Russia. And then you run your detection and you find out a lot of employees are. And then you have to figure out, is that intended? Are they coming from an AWS account? Maybe they are running a server out of Russia for some reason. Maybe you have customers there. And that's when you start trying to understand your environment better, and then tune out expected behavior. And sometimes it's not expected. Sometimes you have to hunt down with IT and engineering and leadership and try to figure out what's happening in the environment so that you can help the company limit risk. But at the end of the day, you're trying to generate an alert for behavior that you know is malicious, and you're trying to limit the amount of alert fatigue and work that you're putting on the team. So it's a fine balance between having really good, accurate detections and then also making sure that everything that is creating an alert is something that can be actioned and isn't like going crazy and spamming the whole team. An example of kind of like an environmental variable that people often run into when they're writing detections is if your IT or engineering department has old user accounts that act as service accounts. So service accounts generally have very different behavior than user accounts. And so if you're looking at like a behavioral detection, if you're looking at actions users should or shouldn't be taking, oftentimes those actions are taken by a service account. So this can generate a lot of false positives in your detection writing, and you kind of have to understand how the IT department and the engineering department has approached building things in the past so that you can account for what's expected and what's not. Evaluating detection, just like a code review, creating a space for peer feedback is really important for people to be able to respond to you and really dive into your research and bring up anything that you might have missed, any edge cases. A playbook. So generally a playbook is how you would respond to an incident. Playbook or runbook, basically the same thing. You want to be able to document all the research that went into the detection, but also how you need to respond to the alert when it's generated. And that's really, really important because if all these alerts are going off and people who are responding to them don't know how to go about investigating, it'll be really, really difficult for them and for you to be able to get good actionable feedback out of it. If your organization's at a maturity point where you're able to build automation workflows, this is a great time to evaluate if that response can be automated and that you don't have to push it on to someone else. So one of the last things I want to leave with for detection writing is when you start, there's a lot of like very like trivial things that you can start detecting on. You can think about how to see if like a user is compromised, understanding regions that a company shouldn't be in, understanding roles that a user should not be accessing. But once you get past these initial detections, you start kind of going up this pyramid of pain, which is kind of a well-known framework for detection and response. And that once you start trying to model complex attacker behavior, detections become really like difficult to write, really interesting to write. And it takes a lot more time to research and understand that you're like bringing value. So one of the things that I love about detection and response is like you get to get all of these like base level detections out of the way, and then you got to start thinking about why would an attacker target my organization? And if they were to target my organization, which paths would they take? How would that show up in my logs? And how can I model that behavior so that if they do take it in my environment in the future, I'm able to detect that complex series of events that are occurring. So hopefully I've sold everyone on detection and response now. But if you're just starting, here are a couple great articles that are pretty easy reads, but they kind of dive into a little bit different parts of detection and response. If you've been in detection and response or something similar, like a blue team role in the past, I've also put some links on the right-hand side that I've really enjoyed that go a little bit more in depth, including if you're interested in that machine learning model aspect of detection writing. O'Reilly has an entire book on it, and it's really good. But with that, that's all I have. I'm happy to take any questions if any came in. But in general, please reach out if you're interested in detection engineering or anything I said. I would love to chat about it.
Awesome. Thank you so much, Julie, for that. I think we've all come across saying that there have been very timely examples, right? So thanks for sharing that. And you're so right, detection engineering as an umbrella term, there are so many different roles that can kind of fit into that or overlap with those responsibilities. So thank you again for that big overview. I'll let you go directly into the Discord channel to engage with the audience there. But thanks again for your time today.